When we think of natural disasters, we usually picture violent, immediate destruction, roofs ripped off by cyclones, or roads split by earthquakes. But some of the most devastating ecological wipeouts happen in total silence. Off the coast of Sumatra in late 1997, a 400-kilometer stretch of coastal coral reef died entirely. It happened in a matter of weeks, and it left absolutely no physical rubble behind. Fish, crustaceans, and the corals themselves suffocated in place, reducing a vibrant ecosystem to a vast landscape of dead calcium skeletons. Core samples taken from these corals showed that an extinction event of this magnitude had not happened in the past 7,000 years. This massive die-off was the result of a precise sequence of overlapping climate and human systems, and atmospheric models indicate those exact systems are lining up again for late 2026. When we fail to map out the hidden connections across Earth's environments, we leave ancient ecosystems exposed to total erasure. The biological collapse began in the deep waters surrounding the Indonesian island of Sumatra. In late 1997, a severe positive Indian Ocean Dipole developed. Intense easterly winds pushed the surface water completely away from the Sumatran coastline. To fill the void left behind, cold, deep seawater surged upward toward the surface. Marine biologists call this coastal upwelling. Water temperatures on the shallow reef plummeted by as much as 4 degrees Celsius, suddenly saturating the local corals with an immense volume of raw, deep-sea nutrients. While upwelling occurs naturally, the massive influx of nutrients in 1997 created a volatile environment. The ocean was loaded, waiting for an external spark. That spark arrived from hundreds of miles inland, across the forests of Sumatra and Kalimantan. An intense El Niño cycle brought severe drought to the region. Massive swaths of land were being intentionally cleared and burned for agriculture. The bone-dry conditions allowed these fires to burn violently out of control. This 4-panel satellite map shows the aggressive spread of the destruction over 4 months. By September, dense red areas indicating severe burning and massive smoke plumes completely dominate the landscape. The resulting smoke blanketing Southeast Asia turned the atmosphere into a massive transport system. Looking at this thermal sweep, you can track the immense swath of yellow and white haze drifting off the landmass and settling directly over the ocean. As that thick haze hung over the water, tons of airborne ash rained into the sea. That ash was loaded with high concentrations of atmospheric iron and nitrogen. Agricultural burning far inland was actively fertilizing the coastal waters, creating a fatal link between the burning forests and the offshore reefs. The heavy rain of atmospheric iron mixed with the upwelled deep-sea nutrients, acting as high-potency fertilizer. This chemical collision triggered an explosive reproduction of marine microalgae. It created a massive harmful algal bloom, called a red tide, that stained the water bright orange. The sheer volume of algae was unsustainable. As billions of microscopic organisms died and decayed, ocean bacteria multiplied rapidly to consume them. Those bacteria stripped nearly all the dissolved oxygen out of the water column, a condition known as anoxia. Without oxygen in the water, the local marine life had no way to survive. The fish, crustaceans, and centuries-old corals literally suffocated to death in the open ocean. The reef collapsed under a microscopic chain reaction, entirely fueled by agricultural fires on land. The death of the reef caused an immediate economic shockwave. Small-scale artisanal fishermen lost their main commercial catches overnight. Local coastal communities, particularly in the Mentawai Islands, relied heavily on reef fish for daily protein. The sudden disappearance of local seafood forced these isolated villages into emergency reliance on food aid. The damage then migrated back to the shore. Brackish water shrimp and fish farms unwittingly pumped the toxic, oxygen-starved seawater directly into their systems, wiping out entire inland harvests. A dead coastal ecosystem immediately creates structural human poverty. Coastal societies cannot survive without their natural underwater buffers functioning normally. Ocean temperatures in the equatorial Pacific are currently surging past historical baselines. Forecasting models show an 80 to 90% probability of strong El Niño conditions, converging with a positive Indian Ocean Dipole in late 2026. We lack the technology to redirect ocean currents or stop a drought. The only variable in this chain reaction we can actually control is the terrestrial trigger, the iron-rich smoke from land fires. Preventing a repeat of 1997 requires strict, zero-tolerance enforcement against peatland burning during El Niño drought windows. It also requires integrating satellite data for sea surface temperatures and ocean color to spot early bloom indicators weeks before they hit the coast. Protecting the ocean ultimately starts on land. If we allow massive forest fires to burn during the upcoming drought, the atmospheric ash will fertilize the water, and we will watch the oceans suffocate again.